All right. So, okay, so 2015 to 2012 is up. So we're just going to do 2015, then 14, 13, then 12. All right, so this is the 2015 May June paper for chemistry unit 2. All right, so hopefully everything moves smoothly. All right. Okay, so number one, based on the IUPAC rules, name the what is the name of the compound above? That's basically what it's asking. What's the name of that?
Wait, can you zoom in a bit more, please? I can't really see.
Alright, it's a bit better now.
Yes, thank you.
What's the name of
Which
the
paper are we doing?
2015?
Okay.
See, IUPAC rules, the name of the compound above is
A, as in apple.
A. Alright, so we're gonna have so this okay, 2 amine and 2 phenol. Alright, so it's gonna be propan. Okay, this is A. I think that is a repeat, right? A hydrocarbon contains 87.8% carbon and 12.2% hydrogen by mass. Its empirical formula is
B.
B. Alright, so all we have to do is just take the percentages as mass and then we divide. Then we just, find the number of moles and divide by the smallest number of moles. So it shouldn't take a lot of time to complete this one, right? So it should be B.
Why they multiply it by 3?
You have to multiply it by 3.
Okay, you're asking why they multiply what by 3?
These, the fraction, no, the ratio that you get, the 1 to, I believe, 1.67. My teacher taught me that if you get like 0.5, you should multiply by 2. Or if you get 0.33 or 0.66 or 0.67, thereabout, you always multiply by 3. You can't simply round up or round down because that would be wrong.
Mm-hmm. Alright, so that rule, but it's a 2.33, right? And 6 and going up, right? Usually multiply by 3. So it's a rule of thumb. I don't believe that I've seen the rule a lot in textbooks, but I've seen my teacher do it for different questions. Right? When she does it on the board, she just does that. And then she just tells us to do it. Right? So you get the more accurate answer. Right? Because some answers are inaccurate when you don't do that, but you still get the right answer. But for some instances, you might get the wrong answer. So it's best to just be accurate at all times. So if you get like a 0.5, right, as Kayla said, multiplying by 2 can help, right? And if you get anything like a 0.3, right, or any type of odd number like that can work. Odd number below 5, right, can work as well. So it's just based on how they do it. For this, I don't believe that you would technically like have to do that, but this one can work without multiplying or anything like that, I believe. I think it can, right, if we look at the ratios properly. But I worked it in 2021's paper, right? So I worked it there. 3,
So it's B
one,
and not E.
it's B, yeah. Right. The equation for
Right.
the equation for the formation of the anesthetic seen here is these two equations, right? So the type of reaction occurring is free radical substitution, right?
Free radical substitution.
Wonderful. For in the reaction between ethene and bromine, which are the following statements about the reaction mechanisms may be true, the carbocation form in the rate determining step, or a carbocation is formed in the rate determining step. Interesting. A dative bond forms between the bromide ion and ethene, or the heterolytic fission of bromine bonds occurs. What do you think is true?
C.
Log.
Okay. All right. So we're hearing C and D. right? Everything else is implied hydrogens, right? So if we look at bromine reacting with this, right? We're gonna have bromine specifically. Yeah, bromine, right? So we know that this is going to be an electron dense area. So the interaction between the bromine and the double bond, right, will cause, what would happen here? What do you think will happen here?
Partial charge, slightly,
Right.
but one slight positive and one slight negative.
All right, so it's going to polarize the molecule. Wonderful. Right, so we're going to have, would it be something like this? Is it going to be half arrows? Does all the electrons in the bromine go to one? Or do they evenly split between both? What does heterolytic speak to? Heterolytic fission.
One going to be positive and one to be
Unsymmetrical
negative.
breakage.
Alright, so within the bond, one sigma bond, there are 2 electrons. So that means that each bromine is going to gain 1 electron. Alright, so we're gonna have this, and then you're going to have the interaction here. Right, so let me just erase to make it make sense. Alright, so if we remove this bromine here, after that heterolytic fission, so we know it's heterolytic fission now, so that means that 3 has to be in the answer. So A and B are out, and we're gonna have the formation of the electrophile here, and the electrophile is gonna be added here. So is it going to be dative in nature? Is it gonna be native in nature? What we're going to have is it going to be dative in nature? What we're gonna have is carbocations. Let me just draw the molecule like this, right? We're gonna have carbocations here. Right, when the bromine adds to one of these carbocations, and you know by Markovnikov's rule which is going to attach to, so I'm not gonna ask that. Right, so what type of bonding is this? Dative or would be dative? Dative, true. Right, so it has to be dative because the bromine is contributing all the electrons to bond. Wonderful. The carbocation forms in the rate determining step. The rate determining step is also known as a slow step, right? Or it is synonymous with the slow step. Now, in this reaction mechanism, would the carbocation formation be the rate determining step?
Think so.
Alrighty. Anybody else? Anyone else? I heard somebody say D, so that's what I want to know.
But like, does the rate determine? It depends on the halogen. Like, if it was fluorine, it would be more faster.
It would be fast. Well, it can depend on that. Yes, it can.
I'll say D.
Alright. So the rate determining step is usually a transition state, right, between 2 starting materials. So you're gonna have your bromine and you're gonna have your is ethylene, right? Is it ethylene you're asking about?
Ethene.
Yeah, okay, ethene, right? I draw propene right here, but no worries. So we're gonna have ethylene, right? So those are just going to be your starting material. Relative energy is gonna be low. The transition or the rate determining step would be the formation of the intermediates, which would have a carbocation. What we want to know is that true? Is the formation of the carbocation the rate determining step? Do we know how to determine that? Because usually the rate determining step is the creation of intermediates. Are you guys following what I'm saying? I'm not sure. Rihanna, Shania, Caroline, Kayla, you guys following what I'm saying? No. Alright, I have a feeling that we're lost.
Sorry, I'm still trying to figure out number 2. That's all.
Figure out number 2. Okay. So we have to really look at this. So is it D or is it C? All right. I think you guys need to know what is a rate determining step, right? So the rate determining step specifically would be, as we know, as this would be the rate, well, the step that determines the overall rate of the reaction specifically, right? It's usually determined by the lowest step, as I said. Well, the slowest step, yeah. And the rate determining step is usually compared to, it's like where the activation energy is within an diagram, right? Where the activation energy becomes higher, that is where the rate determining step is really, right? So the importance of it is really to create some amount of intermediate species. And which one would be intermediate here?
As in which step?
I'm asking if in the rate determining step, right, if a intermediate is created. I'm asking that.
Yeah, I think so.
An intermediate is created, all right? So we're gonna have that. So that means that D would be the best answer. Because it's just that we're looking at, right?
I'm not sure if this will help, but in the study guide it says you will find the term carbocation useful when writing about mechanisms. A carbocation is an alkyl group carrying a single positive charge on one of its carbon atoms.
Mm-hmm.
They are often intermediates in organic reactions.
Right? So yeah, the carbocations are always intermediates because they can't exist stably most of the time. All right, so they will never be end products generally. So within the mechanism, the carbocation is always found somewhere between the first step and the last step, right? So it's an intermediate step somewhere in between. So it makes sense. And the creation of the intermediate is the rate determining step. The same thing, for example, in SN1, SN1 reactions, how the intermediate carbocation intermediate is created, right? So anywhere you see a carbocation being created, right, as Kayla suggested, it is a intermediate, and that step that created it is the rate determining step. Number 5, which of the following compounds will not decolorize bromine, water, but will decolorize potassium permanganate on warming? Anyone?
Ethanol.
Okay, so saying ethanol. Anyone else? Ethanol is just the answer? Yes, no, maybe? Alright, so ethanol will be able to decolorize potassium permanganate because if we oxidize alcohols, right, we can either get, well, there's only one direction it can really go due to chemistry unit 2 or based on the information here, which is probably going to be an ethanoic acid, right? Or it can create an aldehyde. It can create an aldehyde or a ketone depending on which alcohol we're using, primary, secondary, or tertiary, right? And then carboxylic acid, depending on the type of of alcohol again. So I think this would be a good answer here, right? A substance reacts with sodium hydroxide to form an ionic product. Hydrogen gas in the presence of nickel cat. Alright, that's fine. And ethanol to produce an organic compound in water. I think I saw this somewhere in a piece of paper before. It's really similar to a question I saw there. The substance with the properties above could be.
Let's see.
C. All right. Okay. So first of all, it reacts with ethanol and an organic product to to produce an organic compound. So ethanol can react with carboxylic acid to create the organic compound esters, right? So it kind of has to be that. So D is out. It reacts with hydrogen in the presence of a nickel catalyst, right? This is hydrogenation, right? And alkenes generally would have to go through that. Therefore, both of these would be wrong. So C. Right? If it's a sodium hydroxide ionic product, whatever. You try to probably get the answer based off of all the simpler stuff before you have to go through complex chemistry, right? So 2 and 3 is simple to find out. So once we eliminate everything else, C is the answer. All right, number 7. Allow this to clear up. The product of the reaction above is, so we have this product here. So this would okay, so what would this be?
B.
B. All right. That's one question there. All right. So number 8, this right. Diazonium salts are useful in the synthesis of aromatic compounds. Which of the following compounds can be prepared from a diazonium salt?
C.
The coupling reaction, right? Compound X reacts with 2,4-dinitrophenylhydrazine to give an orange precipitate. That means it has to be what?
Carbon
An
dioxide.
aldehyde or a ketone.
So it has to be either this structure. This structure is what? That I drew there.
Ketone.
The ketone.
Ketone, wonderful, right? Or it has to be an aldehyde. So therefore it has to have those groups. So I think C and D would be out, but hold on, let me check something. Tollens reagent to give a silver mirror, so that would be attributed to which compound?
Aldehyde.
Aldehyde, so it's definitely an aldehyde. And aqueous alkaline iodine, right, to give yellow crystals, that would be the iodoform test, right? And that needs a solitary methyl group, true? Right? Alright, so it needs to be an aldehyde with a solitary methyl group. So what would be the best answer? So if it's an aldehyde, this can be an aldehyde, this can be an aldehyde, right? Not sure about that one. This would be sandwiched between 2 R groups, so this would be a ketone, right? If you look at it like that, because yeah, that would be a ketone sandwiched between 2 R groups if it's a carbon.
I'm thinking D.
D. All right. So
I'm thinking D as in dog.
D as in dog. All right. So if we draw out that structure, we can get a solitary group there. All right, let's see. So you're saying that's gonna be a carbon connected to a carbonyl group connected to a CH3 group. So you're saying that this would be the answer. This would be the solitary one we're talking about that will give the triiodoform test. Well, the iodoform test. Why not A though? Just asking.
Because
Go ahead.
Because I'm thinking the CHO would account for the aldehyde, and then for the CH3, you'd also need a OH. Because to get a positive iodoform test, you need C bonded to OH, also bonded to H, and a CH3. But I'm not seeing where it's attached to a OH group.
Okay. On D you're talking about?
No, A.
A, alright. So for the positive iodoform test, you said you needed a methyl group attached to an hydroxyl group?
Yeah. So like you can get 3, right? So you have the carbon a carbon bonded to a hydrogen atom, a OH group, and a CH3 group. But you can also have a positive iodoform test with a ketone with that has a CH3 attached to a
Mm-hmm.
carbon, which is double bonded to a O. And then to that carbon, you also have it bonded to another R group. So I was thinking that R group in this case would be the CH2 in
Right.
D. So that's why
Indeed.
I was saying D, yeah.
Okay. Um. So in order for the iodoform test to work, it has to be an acetaldehyde group, right? So it needs to be an acetaldehyde. So I get what you're saying here. Hold on, let me let in Kayla. Alright, so an acetaldehyde. This would be an acetaldehyde, right? So you're going to have seems legit. Cause I heard you said you need to be onto a hydroxyl group. So like no, but a carbonyl group, yes. So that's fine. But oh, you said the R group. The R group, it has to be attached to an R group in some way, shape, or form because the carbon in the carbonyl group would have to be, bonded somewhere else. So it makes sense. So D is a strongest answer here, I guess. I am to believe, so that's fine. So it has to be an acetaldehyde there. Okay, so which of the carbon atoms indicated by the arrow labeled A, B, C, or D in the following molecule is the most likely site for nucleophilic substitution to occur?
D as in dog.
Okay, D, nucleophilic substitution, interesting. So you're saying it's likely to happen there at the at the carbon of containing the hydroxyl group. So this carbon only has, that's a single bond. Yeah, so that carbon will only have this, right? So it would be a carbocation, right? But it says nucleophilic substitution, though. I guess you guys can tell that I've never seen this question before in my entire life. But this, if you're going to have a nucleophile attacking there, wouldn't it just be an addition, more so than a substitution? Since it's already like gaining, it already has a positive charge, so it won't be replacing anything much. Because carbons would need to have 4 bonds. It's tetravalent, so this one has only 2 bonds. So it will be a carbocation in some form, shape or form. So I'm thinking that if a nucleophile attacks this, it may be just nucleophilic addition.
Yeah, that makes sense what you're saying.
Alright. C, I don't think C makes much sense at all. Just saying. C doesn't make much sense at all to me. B, that ring would have a high electron. Well, wait, hold on. This is alright, that seems fine there. But here though, I don't think it will attack there. It's a nucleophile. Why is it going into a ring like that? I think the only answer we have here left is A. But based on let me see what A is really doing. This is gonna be R. So unless they're going to have, this would be the ring, right? Unless they're going to have like a step where bromine breaks off, right, and increase it could be, it could be. If we use Friedel-Crafts catalyst, I think it could happen. Oh boy, I noticed that the older papers are a little bit more difficult, If we use like a Friedel-Crafts catalyst, let's say that we get a or let's say that we use something like this, hydrogen chloride, for example, just an example, right? There will be an attack here, and it will bring the electrons over here, and then when this is eliminated, it's going to create the carbocation right here. So this can attack. So that would be a nucleophilic substitution, right? So I'm thinking that A would be a nice answer. Anybody has any issues with A being an answer? No? Alright, so
I'm still trying to process everything.
okay, I'm not gonna take it yet then. But you get what I'm saying by doing that? Or is it a bit messy? If we have the generation of a nucleophile, right? Let's see this. Right, what I'm saying is that we're gonna have like, hold on. Let's say that we have the bromine attached to carbon, which has well, the hydrogens here attached to the ring. Alright, so it's going to be attached to the ring. If we have something, for example, hydrogen chloride, just using hydrogen chloride as an example, right? Or I could just write HN, to be very honest. HNU, to just show a nucleophile or a nucleophilic species. Right? We're going to have something like this happening, where, okay, the electrons would actually move from the bromine to the hydrogen, and then these will force these electrons to move over to the nucleophile. Right? If that were to happen, right, we're gonna have the formation of hydrogen bromide, right? So we're gonna have the formation of hydrogen bromide, and then we're gonna have that hydrocarbon, well, that carbonyl group that is still attached, well, it's not a carbonyl group, this R group, this alkyl group, right, which is still attached to the ring, right, with a positive charge, right, allowing for this nucleophile that has just been, you know, released within the solution, right, to attack that right there. Does it make sense?
Yeah, I think it's A.
Alright, hold on, let me put the all the bonds there, and this will move on to here, and that would be
You're saying that for D, it would be like,
for D,
oh,
I
sorry, go
think
ahead.
okay, for D, I think that, right, based on the bonding here, based on the fact that the carbon is sp hybridized, it will have empty orbitals, right? Well, not empty orbitals, it would have free orbitals, and it would have a positive charge because it has nothing to really, like, you know, diminish the charge. There's no more electrons to really diminish its high nuclear charge, right? So I would believe that since it's open, it would just be a carbocation, to be very honest, and then you'll just have an addition there. Because if it's already a carbocation, right, you can just add, and you can see that it's unsaturated because it doesn't have like 4 groups around that carbon. Unsaturated unsaturated species go through addition, so I would believe so. Hold on, let me let in these people. Alright, so can move on to this. 2-hydroxy 2-methylpropanic acid can be formed from propanone in 2 steps as illustrated below. So yeah, we're gonna have this. So it's simple, right? Which of the following statements about these steps may be true? Step 1 involves nucleophilic addition. Is that true? Or step X?
True.
True. So nucleophilic addition, all right? And we know how that works, so I'm not gonna touch anything. Aqueous potassium cyanide is a reagent for step X. Is that true?
True.
Wonderful. And step Y involves hydrolysis?
True.
All right. D is the answer. number 12. Not me saying step 12. So give it a moment. I'm not sure why this always happens. Always takes a while. Which reaction mechanism occurs in the conversion here? Do you think it's free radical substitution?
This was a question I was having issues with because I'm not seeing where anything is being substituted. Not seeing
Oh,
any atom or any groups of atoms being replaced. I'm just seeing the same CH2, CH3, but with an addition of
what?
chlorine.
All of this wrong. I think it's all wrong. Because what? First of all, if we draw out this group, have you seen this question repeated?
Yeah, I think so. Let me check.
Because I just saw something that is definitely incorrect here. So I'm just drawing out that group, this group on the ring, because the ring cannot be wrong. I don't think that makes sense. The ring can't be the issue. What you're telling me here is that this carbon is bonded to 5 different things here. This doesn't make any sense.
It came in 2021. Same thing.
Are you serious?
And over the arrow, you have UV light.
Well, the UV light will give free radical substitution, but what? Okay, I think it is we're just talking about the mechanism, even though whatever is happening with the product looks very interesting. Because that carbon there doesn't make any sense. Because it's bonded to what? Wait, it's 3 dots. 3, 4. Alright. 1, 2, 3. Yeah, this doesn't make any, yeah, the carbon doesn't make any sense for real. But free radicals, I get what you're saying. So you're saying that the only difference with it is that UV light is presented?
For the 2021 paper? Yeah. Let me check.
Alright, so the mechanism, I think the mechanism will still remain as free radical substitution, but I think the product is a bit off. But the mechanism, I think, would still stay true. So it's probably just an issue with the product, right? But the mechanism is fine. Like the mechanism has to occur to create both the wrong and correct answers. So I think the mechanism will still stay true here. But that carbon shouldn't be able to do that. All right,
Wait, can you go back, please?
But you can see what I'm saying, like this is not supposed to happen. You can't just add like that. Because I guess people say
okay, what I'm thinking. Okay, I'm thinking that yeah, the reactant side is okay, but I'm thinking that instead of the CH2 CH3, I think they meant CH2 CH3. So one of the hydrogens was replaced by the Cl, and that's how we got the HCl. So I'm thinking. I'm thinking the CH3. Yeah, I'm thinking it should be CH2 CH2.
Right. So if it's CH2, what would we have? Still be free radical substitution, right?
Yeah,
Okay,
that's what I'm saying. It's just an error.
So you tell me that this error happened this long ago and they still kept it? I don't know what's that, but yeah, so it should still be that. Alright. Which of the following statements is not true of addition polymerization? Only one type of the polymer is formed. The polymer is readily hydrolyzed to the monomer. What is it? Is it B? Okay, it seems like we're gonna take 5 years to finish this paper because is it B?
Yes, the polymer is not readily hydrolyzed
All right,
anymore.
thank you so much. 14. Which of the following compounds will form an aqueous solution with the highest pH? Or in other words, which is the strongest acid?
B.
B, alright, would be the tertiary alcohol. What would be observed when aqueous bromine is added to the following compound? No? Body? What would be? Alright, I think B would be the best answer here. I'm not sure why is it. Should I just answer the questions? I'm not hearing anybody. Okay.
Sorry, I went to do something. Where are we now?
Fine. Question 16. Alright, so which of the following factors will not affect the accuracy of the results in a titometric analysis? Which one would it be?
Boy.
Alright, so adding excess water, yeah, water won't. Because adding excess water is a thing that we can do to clean the pipette as well as the tips of the burette within it. So it shouldn't be able to affect the pH. So, well, or affect the titometric analysis because it doesn't have to be acid base. 17 species which absorb light in the UV vis region have.
C.
Alright, 1, 3, wonderful. Alright, UV vis absorption arises from vibration and rotational transitions from.
I'm thinking B. Wait, no, I'm thinking A. I'm really not sure.
When we talk, what are the transitions that we're talking about? N to sigma star, N to pi star, and pi star to pi to pi star. Alright. So non-bonding electrons would be in their ground state, as well as pi electrons would be in their ground state, and they're going to these excited states right here. So I would believe it is B. Because if it happened within the ground state, you can't have electronic transitions within the ground state. Like, transition means that it goes to an excited state, wouldn't it? Right? An excited state to the ground state, those won't generally be those won't be absorption. This would be emission. Right? So I think B would be the best answer. 1, I think, is impractical. 3 is emission, so 2 is absorption. Alright, so molecular absorption we're talking about. And the absorption always speaks to electrons getting photo excited in the ground state and rising to a higher state. Right? So it's about that. Okay, let me just scroll down. Hold on, why is the screen moving all over the place? Alright. So everybody's fine so far? Okay. So a student carries out, let me just let in this person immediately. Alright, so a student carries out the gravimetric analysis of a soil sample taken from an area surrounding garbage. I think this is the question where like it just asks a bunch of stuff. Right? Let me just check something down here. Right. So these are actually simple. It really just looks like it's difficult. Right. I notice that these tend to repeat all over the place. Right. So we have this entire thing. So balance the equation between lead and that. So D should be the general answer because it would be a 1:2 ratio with lead ions to hydrochloric acid specifically, and then lead chloride would be an insoluble salt, as we all should know. Therefore, lead chloride would be insoluble here, right? So we know that this is garbage and this is garbage, right? But to determine between if it's C or D, then it has to be D because it is solid and not aqueous. Right, what is the concentration of lead ions within solution? It's a 1:2 ratio, so we can find the concentration of hydrochloric acid, then use the ratio to find the concentration of lead ions within the solution. Right, what was the answer here? We did this before, right? What was the answer here?
I think I got B.
So the answer was to I think the answer was to the negative fourth power for real. Let me check. I had some papers here from yesterday and I wrote out some things on them. It was alright, so all of the units were the same, right? And I think B would be was the answer that we had. Right? So some pretty simple mole concept though, so it shouldn't be a problem for anybody, whether or not they put new questions about for mole concept. Which of the following materials are commonly used, well, stationary phases in chromatography?
B.
B, wonderful. Moving up, 20. All right. A compound, okay. Yeah. Right, like it repeats, right? So all we have to do is times this by 10 to the power of 6, right? Times it to a million, right? To get it from megahertz to hertz. And then we plug it into the equation. Which equation do we use? Lambda is equal to what? Well, that's not lambda. Lambda is equal to what? Nobody? I'm just gonna write the equation and we're not gonna do the entire thing. Just write out the formula.
Speed of light over the frequency.
So lambda is equal to the speed of light over the frequency. Wonderful. Which of the following relationships is true for the absorbance of UV vis light by a solution or concentration C? So it's always A is equal to epsilon CL. Wonderful. Beer-Lambert's law, right? It's really simple. 24. Which of the following regions of the electromagnetic spectrum best matches the wavelength ranges of P, Q, and R? What would this be?
I put C.
Okay, you put C. All right. What is the relationship between frequency and wavelength?
Longer wavelength, lower frequency.
Lower frequency, right? So that means that which one of these would be have the longest wavelengths? IR, right?
Yeah.
Okay. So IR would be over here. And then it would be UV, and then it would be X-rays, right? Or wait, what would radio waves be? Where would radio waves be? I think that's probably the determiner here. Where would radio waves be?
It would be like before P, like way closer to the 10 to the positive 8.
Okay. All right. So it would be
Radio, then microwave, then infrared.
Mm-hmm.
So it would be, yeah, more towards the left.
Right. So you're gonna have long radio waves, then you're gonna have like AM rays, FM rays, Wi-Fi, like then microwaves, then IR for you. And then after IR you're gonna have the UV, well sorry, the vis, then the UV, then X-rays, then gamma rays. Right? And since X-rays and gamma rays are so, put together like that, right? Because of, what you call it now, radioactive isotopes, right? That's why X-rays can be damaging, and some doctors that work with X-rays over a long period of time may get some amount of development of cancers, right? But it shouldn't be too much of an issue. 25. Which of the following processes occurs in a mass spectrometer before isotopes can be detected? We know that amplification is not a part, right? So it'll be 1 and 3. B. A mixture of gases containing methanol, ethanol, propan-1-ol, and propan-2-ol was obtained from a refinery. What method can be used to separate these gases for analysis? What would it be?
C.
Gas liquid chromatography, right? So you should probably realize that everything else is not separation techniques, right? High pressure liquid chromatography, we won't generally use that, right? So they all have similar boiling points, right? So 27. What transitions are expected from this? So it would be all of them, right? So the answer would be C. Just moving on. Which of the following species is not a significant fragment from the mass spectrum of ethanol? T. Right? I think because they repeat, we can just go through them. If you have a question, you can ask the question, or you can say, wait, hold on, go back, or something like that. I don't know. So give this a second. Which of the following compounds are the main impurities in bauxite? Which are the main impurities in bauxite?
Iron and silicon.
Iron and silicon. 1 and 3. Everyone agrees? Lead oxide.
Yes, sir.
Not lead oxide or calcium carbonate. Okay, component X contains 3 compounds, P, Q, and R. Component P is needed as well. Okay, we're just looking at which one of the chromatographies would give us the pure sample. Alright, and this would be
A.
column chromatography. Which of the following processes is not involved in the manufacture of ethanol?
C.
C, dihydration of ethene. Alright, so remember that within that process, what was it, an aldehyde? Hold on. Ethaldehyde would have been created, and then you create ethanol, so it wouldn't be dehydration of ethene. But you guys know Unit 2 biology like the back of the hand, so you guys would have figured that out immediately, right? Well, if you have done the biology. 32. The chlor-alkali industry is an electrolytic process? Is a redox process? Is this for making bleach? Is that all true? Yes or no? No one? Okay. I'm gonna give you guys one more second. Yes or no?
I don't know.
I don't know.
I'm thinking all 3.
Alright. Okay, so wait, question, right? The person who said you don't know, I think it's Matthew, right? Is it important for making bleach? Do you think that's true?
Bleach is sodium NaClO.
Yeah, hypochlorite. Or you can use the chlorates to make it. Alright, so well, the chlorate could probably be it. So it's needed, right?
Yeah.
Okay, so notice that in electrolysis, we have something happening at the anode and something happening at the cathode. And we know that through redox chemistry in Unit 1, that redox chemistry and redox equilibria is all about cells and electrolysis. So in order for electrolysis to occur, a redox reaction must occur. Therefore, electrolysis is always a redox process. So if you have 1, you have to have 2. And if you have 2, you have to have 1. And 3 is right. And 2 is right. Therefore, 1 is also right. So it's like that. 33. Which of the following occurrences may be a result of the light-induced reaction of pollutants in the air?
B, as in boy.
B. So we say 1 and 3. So why not photochemical smog? How is that created?
No, I said B.
Or B? Oh, you're saying photochemical smog alone? Alright. So light-induced reaction, alright. For the greenhouse effect and global warming, we're looking at usually light within the IR spectrum that causes molecular vibration and redirection of light back onto the Earth's surface. And then as we increase the concentration of gases within the air, right, that redirection of light, right, traps the photons, right, in everywhere under the stratosphere. So the Earth just continues to warm. So it's not necessarily an huge chemical reaction, but it's more like molecular interaction, right? So it's something like that for 1 and 3. So I think 2 would be the best answer, right? 34. Fermentation of sugars to alcohol is controlled by an enzyme complex mixture known as zymase, right?
Yeah, B.
Okay. Beautiful. During an earthquake, household water supply is most likely to become polluted by Alright, A would be the best answer. Repeat?
A as in apple.
Okay. I heard C a while ago now, so we'll have to stop the recording. Alright, so 36. Can't see the question yet. Okay, the FDA regulates the use of food additives and requires isn't this from a foods paper? I saw this question before. First I was seeing it on chemistry paper though. Not to be used. Alright, so requires that the additives not to be used to disguise the faculty or inferior products, to enhance the color and flavor of food products, or when they significantly destroy nutrients. What would be it?
I think it would be D.
Immediately 1 and 3. So the FDA does heavily restrict those things, right? Well, I wouldn't say heavily. They try to regulate those things, because you notice that even though we said, like, for example, in biological genetic engineering and stuff like that, it can increase the yield of food products, but it usually destroy nutrients. So the FDA kind of try to regulate that as well as additives, right? So, okay. Flocculation is a process involved in the What's flocculation? I haven't seen this word in
I
a
put
while.
A.
Go ahead.
I put A.
A-Y. What is flocculate?
I remember Googling it and I remember putting A.
Hello.
That's all.
Okay, alright. But I remember Googling it. I mean, it is true. Alright, so we have that there. Because we have charge neutralization, then we had the flocculant into the flocculation chamber, and then we get microflux, right? And then it actually creates sediments on the bottom, right? So it precipitates impurities to the bottom, right? So the chlorine is an is an active component for swimming pool disinfectants, although it is a poisonous gas. Which of the following salts is used as a safe chlorine source?
C.
C. Alright. We can get chlorine from that. That should be fine. 39. In which layer of the atmosphere is ozone detrimental to human health and vegetation? Which sphere?
C.
The troposphere, alright. Wonderful. This paper is fine. It's not too bad. Paper is not too bad. Alright, so which of the following outcomes are advantages of using incineration as a form of solid waste disposal? All right.
All three. Yeah, all three.
Okay, hold on. Let in Chanel. Alright. So all three. This is fine. Chlorine can be produced by the diaphragm method and mercury cell electrolysis. Which of the following statements are true regarding diaphragm cell method? More efficient and less harmful, right? So 2 and 3. Then we have 41, waiting for it to load up properly. Okay, the appearance of a bright, red precipitate on the formation of the iron nitrate, right, to a sample of water indicates the presence of
D.
D. Hold on, let me accept Alexis here. Alright, so you said D as in dog?
You were saying something to me?
Yeah. I'm
Didn't hear.
asking,
Can you repeat?
why do you say D as in dog? Is that what you said for the answer?
Yeah, I said D. Because I remember going through the document. Let me pull it up real quick so that I don't embarrass myself. Let me find it. Oh, so it's called the thiocyanide ions. It says when iron 3 nitrate is added to a solution sample containing thiocyanate ions, the formation of a bright red precipitate suggests a positive test for it.
All right. So the thiocyanate, because we know that anything that contains sulfur is thional, right, in nature. So it's theo. Anytime you hear theo, it's sulfur we're talking about, right? So it's a thiocyanate ion. So what we're gonna have is a substitution reaction, and we're gonna have the creation of the red precipitate with iron, right? As we know, well, yeah. So you're gonna have a red precipitate with iron. So it's like a substitution ish, right? So that would detect thiocyanate within the water per se. So we have that there. 43. I hate this question. Chlorofluorocarbons undergo homolytic fission by being exposed to ultraviolet light in the stratosphere. Which radical could result from that? What's the answer?
B.
Alright.
B as in
Alright.
Can you explain that?
Okay. Let's see. Give me a second. Let me draw it out real quick.
Hold on. Never mind. I understand.
Oh,
The
alright.
chlorine will be the easiest to come off, right? Yeah, I understand.
Alright. So let me scroll back a little bit. A sample of crude oil contains octane, right? In which crude oil fraction would you expect to find this sample? Naphtha and gasoline? Naphtha and gasoline, right?
yeah.
If you could remember, octane is used for like jet fuels, so I guess you could connect it to like gas for jets, which is like gasoline. I don't know if you want to make that connection, but octane is used for jet fuels, right?
But
So
you know that,
go ahead.
you know that, and that is C.
Oh, it's based off of the number of carbon chains, right, that are grouped in different categories. So refinery gases are usually like carbon 1 to carbon 4, thereabouts, right? There's another group from around carbon 8 to around carbon 13 to 14. I think that would be naphtha and gasoline. And then you just have to have the table. I'm not sure. Does anybody have the table? 'Cause I think it's memorization for the most part. So if anybody has a table concerning the group for this, that would be helpful. Because if you memorize the table, that should be fine. The principle of it is that as you get closer to refinery gases, you have a smaller carbon chain, and as you get closer to bitumen, you have a longer carbon chain, right? I think we discussed all of this in fifth form, right? Chemistry. So that's the thing, but categorizing them into different fractions, that different thing. So if we have a table, could we send it in the group, please? right?
Okay.
But that is what's there. I think some persons got it from like the study guide, I believe, or a textbook. So just wait to see if they send the table and then you can have a look at the table and see what it says for yourself. Thermal pollution results in less dissolves oxygen in water. Alright. You know that, hold on.
Remember the question that I did and they talked about if temperature have an effect on oxygen concentration in water.
Mm-hmm.
And you guys said D, so why could it be? Well, we'll find something to prove.
Alright. Okay. Alright, so that would be the end of this, I guess. Alright, so that would be the last question here. That would be the chemistry unit 2 2015 paper.